All right, this video is going to go over geometric sequences, so let's go ahead and get started. The first thing you need to know is you're going to be using this equation, a sub n equals a1 times r to the n minus 1, okay? Where a1 is your first number or your start, r is your rate, and then n is the number of the term you want. And this a sub n is going to be your output whenever you input that n number. And these n's will match. All right, so the first thing they want you to do is they want you to be able to graph a geometric sequence. So basically, you're just going to label these are outputs. So you're going to label them with their input. So this is the first term, second term, third term, fourth term, fifth term. And you can make coordinates out of this, like 1, 4. It's like an x, y coordinate. So 2, 2, 3, 1, 4, 1/2, and 5, 1/4. And then you're just going to plot them like you would any other x, y coordinates. So 1, 2, 3, 4, 5, and I need all the way up to 4 on my y values. So 1, 2, 3, 4, and just plot the points. So 1, 4 would be here, 2, 2 is here, 3, 1, 4, 1/2, 5, 1/4. It takes the shape of an exponential curve, but you don't connect the dots. It's just a series of points. It's not an actual line. So that's how you would handle number 2 as well. All right, so we're talking about geometric sequences. In order for it to be considered a geometric sequence, it needs to be multiplying by the same number every single time, by the same rate, right? So like look at number 3 here. You're timesing by 4 every single time. So yes, this would be geometric. This next one, yeah, it has some fractions, but you can kind of think of it as you can take any far term and divide it by the previous term in order to get the rate. So it'd look like 4/9 divided by 2/3. If you did that, you would get 2/3. 4/9 divided by 2/3 is 2/3. All right, this next one, it's multiplying by -5. And then this next one, it is adding 2 each time. So this is arithmetic. It's not geometric. All right. So if they want you to find like the next 3 terms, you gotta go get your rate. Your rate is basically, you can think about it as any far term divided by the previous term. Or if you want to stay consistent, you can just do the second term divided by the first term. So like 30 divided by 20. This is 3/2. That's my rate. And so to get these next 3 numbers, I'm just going to be multiplying by 3/2 over and over and over again. So you'll get 67.5, 101.25. And you could do it as a fraction as well, but most of the time with these, you're going to be using a calculator. So you're going to have a couple decimals. So that's how you would do that. So like this next one, I would do 1/2 divided by -1/4. And if you did that, you would get -2. That's your rate. So to get your next 3 terms, just go multiply by -2 over and over and over again. So you'd get 2, -4, 8. Okay, now on these, you're going to have to go get your equation. So remember the base equation was a sub n equals a1 times r to the n minus 1. And then you're just going to plug stuff in. So for like this first one, you're going to be like, okay, they want a sub 4. Well, that's going to be a sub 1, which is 7 times r is 2. And the n is 4 here. So it's to the 4 minus 1. And then you can just punch that in the calculator, or you can work it out by hand. You would get 56 there. So that's how you're going to do like this next one's basically the same thing. These over here are the same. This one's the same. This one's the same. So that's how you're going to do all those. For 13 and 14, though, you have to get A1, which is your first number. So like A1 is 7 there. And you also need to get your rate by taking, to stay consistent, the second term divided by the first term. So like this one's 3. Now I could write my equation to find A9. It would be A1, which was 7, times the rate, which was 3 to the n minus 1. N was 9 there. So if you punch this in, you'll get 45,927. But that's how you would do these other ones. It's just fractions over here. Your R is going to be -1/4. And so on these, though, I will say if you're using a calculator, you have your A1. And so to find A7, it would be A7 equals A1, which was 1, times, you need to use parentheses whenever you have like negatives as your rate. So it'd look like -1/4 in parentheses to the 7 minus 1. This is how you need to type it into your calculator, because if you just type 1 times negative, and then you put 1/4 to the 6 or 7 minus 1, it'll apply this negative later. So this is no good. Use parentheses. All right, so that's how you would do all those. Let's look at this next page. If they say they want 3 means between these two numbers, basically they're saying your first term is 1, then there's going to be 3 geometric means there, and then 256, right? So if you think about this, here's A1. That means this is A2, A3, A4, A5. All right. The long version of what's happening here is you're timesing by R to get to A2, and then you're timesing by R to get to A3, then you times by R to get to A4, and then you times by R to get to A5. So you can think of it as you times by R 4 times to get to 256 from your start of 1. I hope that made sense. The short way to do it is just take this number minus this number. So that's 4, right? 5 minus 1 is 4. That's going to be your exponent on your R. All right, so anyways, here you would get R equals 4, because you get R to the 4 is 256, and you fourth root it, you would get 4. And once you know R is 4, you can just times by 4 over and over from your start to get these numbers, like 4, 16, and 64. So that was kind of a long explanation on that. Let me show you the kind of the short way to do it. Look at the next one. You have 3, 4 means, and 96. So this is A1, this is A6. So that's a difference of 5. So R to the 5 is going to be 96 over 3, which is 32. So R to the 5th is 32. That means R is 2. Now I can just go times by 2 each time. That's the short way. This one just means put one mean in between 6 and 216. So, and then that's how you're going to do all of these. Now this number 21, you have to realize this is A3 and this is A6. And so it'd be like, okay, 6 minus 3 is 3. So R cubed equals 96 over 12, which is 8. So R is 2. And now you could kind of work your way forward and backwards to fill that in. Okay, now on this next section, you're basically going to be doing the same thing there. You're going to have to go get R first. So this was a difference of 2. So R squared equals, then you divide them, 448 over 112, which is 4. So R squared is 4. That means R is 2. Now, to get A1, though, you have to use an input and an output in your equation. Here was the equation again. A sub n equals A1 times R to the n minus 1. All right, so here is my output when the input is a 5. So it's going to look like this. We said my rate was 2. Let me make that in red. That way you know where I'm getting that 2 from. It's from right here. All right, so now you can kind of just punch this into a calculator, I'd start right here with the exponential part. So that's 2 to the 4, which is 16. So you end up with 112 equals A1 times 16. And you can just divide that. And if you divide that, you'll get 7. Just like that. So that's how you're going to do all of these. Let me show you one with the fraction because y'all usually struggle on those. All right, so there's a difference of 3 here. So r cubed equals 1 over 16 divided by 1/2. If you do this, 1 over 16 divided by 1/2, you get 1/8. So r cubed equals an eighth. That means r equals 1/2. All right, so now that I know that, I can use that equation, this one right here, with an input and an output. You could use either one of these. You could use this one if you wanted. I'm just going to use the first one. So output of 1/2, we're looking for A1. We know our rate is 1/2. And the N, we're using 9. 9 was our input there. So this one I would probably use a calculator for. But basically, you're going to get 100. This right here is A1 times, this makes 1 over 256. So if you divide 1/2 by 1 over 256, you'll get 128. So that's how you're going to do that section. Now, this next section, the first one's easy. The second one's really tricky. We're timesing by 4 each time, right? So that means this right here has to be whatever 32 times 4 was, which is 128. So you just go, okay, well, 128 has to be 5y plus 3. And then you just solve that. That one's easy. Let me show you 27 though. 27, you're probably going to struggle with. You need to realize that y plus 1 gets times by r to become 2y minus 1, which gets times by r to become 4y minus 3. So what that means is 2y minus 1 divided by y plus 1 is r. R is also 4y minus 3 divided by its previous term, which was 2y minus 1. So what you can do here is you can set those equal to each other. Like this. So now I've got fraction equal fraction, and I'm going to cross multiply. You have to run FOIL. You'll get 4y squared plus y minus 3 equals 4y squared minus 4y plus 1. The 4y squareds cancel. Get your y's on one side and your numbers on the other, and then divide. So y is 4/5. It's kind of a tricky problem. Okay, now this last section. 28 is one that I kind of really had to think about. Basically, here's your output right here. Negative 10 to the negative 16. It's equal to your first term, negative 10, times r, which is 0.1, which is 1/10 to the n minus 1, right? And we're trying to find n. Okay, the first thing I did was I canceled this negative with this negative. So now I've got 10 to the negative 16 equals 10 to the 1 times 1 over 10 to the n minus 1. Now, the way that you win on this problem is you realize this part right here. 1/10 is 10 to the negative 1. So when you do power to a power and you distribute that negative 1, this is what the equation becomes. It's now a 10, base 10, to the negative n plus 1, like that. And the whole reason I'm doing this is because I want to get these bases the same. It's just going to make my life a lot easier. So now you can combine these exponents. And you can just go solve. Once you get base equal base, you can set the exponents equal to the exponents. That one's just a little tricky because of, first of all, canceling the negatives right from the start. And then this green part where you have to change 1/10 to be 10 to the -1 and then distribute the -1. All right, let me show you another one of those, 29, because those are kind of tricky. Okay, on 29, I know my output is equal to my first term times my rate to the n-1. So the first thing that I did was I did this power to the power. Becomes, you have to distribute it, so it becomes 3n-3, like that. And now I would combine these exponents. You're adding them. And now you can set these exponents equal to each other and solve. The key there was distributing that power to the power right from the start. So this one's 8. Okay, this next one's pretty simple, so I'm not going to go over that one, but I do want to talk about 31 and 32. We are going to assume that whatever you invest or you start with is A1. So that's how much it's worth for that whole first year. That's the assumption we're going to go under, meaning these rates, if they're doubling or they're losing 2%, that doesn't really take effect until the second year. So what's going to happen is you're going to get these equations. A sub n, well, they want the 8th year. See, 8th year is your start amount, which was $100, times your rate is doubling. So that's a 2 to the n-1. So that's all you have to do. Punch that in the calculator, you get 12,800. Just like that. So this last one, it's depreciating by 2%. 2% is 0.02 as a decimal. So if it's going down by 0.02, you started at 100%, aka 1. You are losing, so minus 2%, aka 0.02 every year. 0.98 is your rate. I hope that made sense. So your equation is going to look like, they want the fourth year, your start amount times your rate to the n-1. And so you just punch that in the calculator, you'll get 11,294.30. And these are dollars. So that is how you do geometric sequences. They're not that bad. Just know this equation, know what everything stands for, and practice. Hope this video helped.